All right, so I'll start out by saying welcome everyone to the Seattle Code Crafters Meetup. We're a group that is language agnostic. We care about quality in our code and our applications. We care about our processes, doing the right thing as we make software. Today, Garrick is going to join us and talk about yak shaving. I've known Garrick for, oh gosh, I don't know. Are we talking like 5-6 years now?
At least somewhere in there. Yeah, we originally ran into each other at Agile Northwest and eventually ended up working together a couple times now.
Yeah.
So,
yeah. Yeah, that's all I have to say about that. I'll let you just take it away.
Okay. So, a little about myself in general and kind of where.
Oh.
You're muted.
Sorry, I muted you there, Garrick. Can you start again? That's my fault. I totally muted all, thinking I would make sure that no one was talking over you, and then,
No problem. I was going to give a little bit of general info background. I started out as a professional developer around about 97, been through a variety of technology stacks. I got into kind of XP and craftsmanship in the early 2000s. And somewhere along the way in there, when I started out, was working on an XP team, I came across the book that I thought was really kind of one of those, wow, this is a great book. Why aren't more people familiar with this? And I shared it with my team at the time. I was working on an XP team. I even sent away I got a poster that had the 9 rules printed out on it and had tacked it up on our team wall, and got the company to buy a few copies of the book. And we even did the kind of like a little book club around it. And it was a useful thing. It gave us a good framework to talk about our debugging process, and that kind of became part of the team culture. And the book went on my shelf, and I went on to do other things. And looking back, literally years later, in fact, this year, I started thinking to myself, I had questions from folks who were new to development, and people were asking, it's like, hey, so someone's new to development, just starting out, what are books that they should really have on their shelves? And a couple, of course, that came to mind. The first one, of course, I'm also a big fan of, Pragmatic Programmer, which a couple of years ago celebrated its 20th anniversary. So much of that has really held up, and with a lot of rewrites. If you haven't seen the 20th anniversary edition, they made some great additions and improvements and new context for sort of things about the way the development world has changed 20 years later. But also the other thing that came on was like, hey, that Debugging Rules book. And then I thought, you know what? I don't know that I've talked to anyone else who's, oh yeah, I know that book. And I thought, well, let's take a look at it. And I went through, and the rules are fairly straightforward because there's only 9 of them. But what gets into the book is a number of highlighting points and a bunch of stories that give context. This is a very fun, grab a cup of coffee or something and sit down and read through sort of book. It's not one that you're going to grab a pencil and make a ton of notes on or something. It's kind of a fun book and makes you think and gives you a good context. So that's kind of where this came from. As I mentioned, I'm not the source of these rules. And when we get into and we go off to build software systems specifically, it's all about solving problems. And I started thinking, it's like, well, in a lot of cases, we end up debugging in small ways, probably a number of times a week that we don't even necessarily are aware of. So putting those contexts together, I thought, you know what, this is something worth putting out there. So I'm putting this out there kind of in an attempt to give a little more of some mental anchoring. The next time that you're in, find yourself in a debugging context, that you can be familiar with these rules, think about them, think a little about the context that I go through today and talking about these, and see if it's something that will, as I've found in the past when I've stepped back and looked at debugging as a practice, see if it's something that gives you a better grip. And when it comes to yak shaving, which is a little bit about the title, a lot of times when we're doing something to do something else, those come from a lot of bugs. A lot of, oh, there's a problem here. Well, how many different ways could I solve that? Do I want to solve this permanently? Do I need a quick fix? Some of those contexts and ideas will come up a little later. Going back to the concept of getting off, going off and having to do something and getting delayed with sort of yak shaving activities is when those yak shaving activities start to get bug related, what can you help to anchor yourself? So not only here on the frame, but if you have the picture of me for my background, this is the infamous kind of first bug found in a computer. Interestingly enough, Thomas Edison actually talked about bugs in electrical circuits, going all the way back to the 1870s. But in 1947, I believe this is the Harvard Mark II, the infamous first actual case of a bug being found. This is from a notebook. The moth that got into relay number 70, panel F, was actually taped in. This image behind me is actually in the Smithsonian. The first computer bug, as it were, is preserved in the Smithsonian. And after that, bug and debug kind of became standards. As common as if else, the idea is, oh, there's a bug, oh, we need to debug this. The book that I took all these concepts from, the author's 9 rules and the stories, you can find it at your preferred bookseller, possibly find used copies, but effectively everything that I'm going through is kind of condensed version of this book and its highlighted points. So 9 rules for debugging. And they look pretty simple, pretty straightforward. Some of them you may even think are obvious, but some of the fine points on these get a little interesting. And so it's the fine points that we'll go into that I'm possibly looking forward to folks open to throwing out a discussion point, suggestion. Towards the end, if we want to share war stories, that's going to be something that I'm sure we can very much do. So if you have a war story, I'd ask maybe if you hold it more towards the end, just so that we keep some good pace. Make a note for yourself. But if you've got a question, some clarification, please ask. And in the meantime, we'll go on and look at number 1. First off, it seems self-evident, but the author said that this is the first rule for a reason, and that's the most important. Understand the system. And when you get into it, one of the challenges, as the infamous character Donald Rumsfeld would say, you don't know what you don't know, or there are unknown unknowns, right? And that's one of the problems a lot of times when it comes to bugs, is you don't necessarily know everything. So one of the first places you can do this, and this gave me 2 images for some reason, read the manual. If there's a manual or some sort of documentation in terms of understanding the system, take a look at that. And of course, not only read the manual, but as we can see with this Newtonian reference here sitting under what might be an apple tree, read it in depth. Some things you might skim, but if you can get some depth on it, if there's something related to what you're trying to investigate, don't necessarily skim, confirm things. Because ultimately, one of the challenges is you want to know the fundamentals. How should something fail? How should it not fail? And in doing that, when you're looking at a system, you need to understand the roadmap. Know how things are divided up. If you've got a bug that you think is in one part of the system, are you sure? Can it be in that part of the system? Is that the right part of the system? If you were to trace it, How far would you have to go through? How many different stages does input go through, perhaps, to get to the point where the bug occurs? Can you name all the stages? Do you know what they are? When you've got, sorry, this is annoying me. It's popping up 2 at a time for some reason. It's supposed to only be popping up 1 at a time. So thanks, Google Slides. Understand your tools is another aspect of understanding the system. If you're inspecting and making adjustments, make sure that your tools are doing what you think they do. If you're doing something, you can say it's righty tighty lefty loosey, but sometimes things are reverse thread. And when you think you're actually opening up the flow, you could be restricting the flow by grabbing that wrench and moving that valve. Also, look up the details. This is kind of an interesting factor. When you're under stress, you don't want to trust that you'll remember something. Fun factor of these that I'm sure folks have been bitten with before. Great example of this. Well, the default value is blank. Is it? Did that change between major revs of that software release? Oh, the default value used to be X. Now all of a sudden the default value is Y. Oh no, we just did a major rev upgrade. Our code was relying on this being the default. Now that is the default. So there's another classic example in terms of situations regarding understanding the system. So that's rule number 1. Rule number 2. This is a fun one, of course. And everyone out there who hopefully likes to do TDD, when you get a bug and you've got a good system and you're working with something that you've worked with your team and you've pretty confident you understand because you've written it. This can be a lot of fun. This can be, oh, great, this will be awesome. All we need to do is write a test and show that it fails. Let's rock and roll, right? Well, you can, but in order to do that, of course, there's a few interesting steps. For starters, even when you're going to make it fail, you still want to figure out a way to start at the beginning. This is an important aspect in terms of killing your assumptions. So even if you think you know where something's going on, that's fine to have a hypothesis. But in going through and trying to make it fail, you want to start at the beginning. Specifically, an important aspect, you want to be able to do it again the exact same way. Ideally, and that's the fun part, of course, if you can get it isolated, get it working like with a test that illustrates the failure, you want to be able to make it fail repeatedly the same way on demand every single time. That's where you know you've got something isolated. Interesting challenge with this. Don't stimulate the failure. Good old cup of coffee there. Or sorry, I did that wrong. Stimulate the failure. Give it the input. Give it the input that you want so that it causes it to fail. Give it the right data, put it in the right state, stimulate the failure. Do not simulate the failure. In some situations, you could put in comparable data, similar to what might be going on in the real world that's causing the issue, that you may get the bug, but it may not be the exact same bug. It's an interesting fine point, depending on what's going on, and given a complicated enough system. 2 different sets of inputs, of course, with a problem could reveal 2 different bugs. And if you're not careful, you could go through and actually, I don't know if anyone else has done this, but I know I have. It's been a little while. You actually find another bug because you accidentally gave part of the wrong input. You thought it was close, you weren't quite right, and so you didn't get that same bug. You maybe got a different bug. Another factor, and these are some of the worst, intermittent failures. The best thing you can possibly do, apart from tearing your hair out, is verify everything you can to identify these. These are terrible. If you've ever had to deal with an intermittent failure, trying to figure out and enumerate all of the possible inputs that are going to cause an intermittent failure are a royal pain. Sometimes this requires getting in and doing faking load. Sometimes stuff like record and playback. Intermittent failures are a real pain. But even if you're having challenges, hi Boo. Even if you're having challenges varying everything you can, another tactic for intermittent failures, record everything. If you can capture all the information of what's going on, even if you don't think it's relevant, having that and being able to go over it puts you a little bit in the mode of the sports coach, right? You film the game. You know, there was a terrible play. It was totally messed up. What happened? What did we do wrong? It's a lot easier to take a look at everything in some case, even if you have to sort through some of the noise in order to get a clearer picture of what's going on, because things that you think may not be relevant could be relevant to the situation. Again, particularly with intermittent failures. This should have a not sign through it technically. Don't trust statistics too much. The old joke, correlation is not causation. They can be helpful. They can steer you in the right direction, but sometimes they're not, they're a secondary indicator at best. And then last but not least, this is kind of a fun image in terms of making it fail. This is a classic one because I hear people say this. I've said it myself. You need to know, sorry, second to last, you need to know that can happen. It's like, oh, that can't possibly happen. Oh, really? We got a bug right in front of us showing that this happened. Yeah, that can happen, clearly. And last but not least, if you've run into this before, it's been a while, but I've ended up checking stuff in, squirreling it away in a personal archive, putting in a subdirectory of a project. Never throw away a debugging tool. If you come up with a handy dandy little script that helps you isolate something, or maybe it's a way to dump some customer data and spin it up for a certain application and get it going through on your desktop system where you can run your debugger, as opposed to trying to pile through logs that's on test. Hang on to those tools. Make a note on the wiki, add it to your troubleshooting page for your project. But if you take the time to build up a useful debugging tool, hang on to it. All right, that's number 2, make it fail. Number 3, this is a great one because we love to pontificate. And when we're stuck, it can be more fun than actually digging in. But the sad truth is, you really kind of want to quit thinking and look. You need to see the failure. Unless you see it, you can't fix it. This, you can probably recall in the past, gets historically difficult when you've got a big separation or something that's data driven and there's a lot of drift between where the bug's happening in like prod or test and what data or what environment you might be able to set up on your local development environment. This can be crushing when you're having trouble seeing it because you can't, going back to rule number 2, you can't stimulate it. You don't have the same information to stimulate it in order to see it. In terms of looking, you want to see the details. Don't just inspect at a high level. This gets really important when you start to dig in, sometimes looking lower. Some of the helpful stuff here that you probably run into. Don't just take a look at what's showing up on the web page. Turn on the inspection, of course, in your Chrome browser and see what the actual response was. What's in the headers? What's ripping around? Don't tell me necessarily what the browser has decided to show. What was sent back? What was the dang HTTP response all the way out? when you can, it's really helpful for your app if you get the opportunity to build some instrumentation in. Sometimes people are already thinking about and doing this. Again, keep in mind, this book came out in 2006. Not so much with the cloud deployments and the world of inspecting and looking at everything that's going on. I think in some cases, this is a little easier to do today because there's more things out of the box. But even some simpler tools, some of them freely available. I know in the past I've run through stuff that will help do instrumentation built in. There's lots of libraries and stuff out there that will help you do that. If you can't build instrumentation in, it's a blood pressure cuff, believe it or not. This is what that icon is supposed to be. You can always add on some instrumentation, analyzers, scopes. In the nitty-gritty world, if you get down to some sort of a problem, how many have had to reach for Wireshark? And then, of course, I know there's a leak in this tire somewhere. Give me a shallow bucket of water and some soap bubbles. I'll find it, right? Add-on instrumentation. And of course, don't be afraid to dive in. So it's production software. It's broken and you have to crack it open and fix it. Cool. Do what you got to do. And of course, one of the challenging things you've probably run in before, of course, I know I have, particularly with the insidious world of multi-threaded code, watch out for Heisenberg. Now, as some people will correct me, it's like, well, the Heisenberg principle doesn't state this, but the notion, you look at it, you change the system, you put in those log statements, and all of a sudden the problem goes away. No, the problem did not go away. You changed the behavior in the environment with the threading, and you've hidden the problem. Congratulations, you've hidden the problem. You did not solve the problem. Then you need to start asking yourself, okay, so what's going on here? What do we really need to address that's causing this sort of behavior? And one of the last element here in quick thinking and don't look, it's okay to guess, but you want to guess in order to focus the search, right? One of the more sporting ways to go through this, especially when you're working with people and bouncing ideas off of them, which we'll get to one of the other rules later, is go with your hypothesis. Put a hypothesis up, bash it out, see if you get indicators of yes or no, and use that to direct where you're looking for. Let's see. Next up, number 4. This is a fun one. Going back to that approach, divide and conquer. If there's any way you can reduce the problem space, right? Binary search for the win. Let's say halfway through the system. Is it going on here? No, fine. We don't have to look at that half of the system. Cool. Now, a little contradictory to some of the earlier stuff where you need to understand the inputs, but in some cases, these are kind of why the rules are coming in this way. Assuming you understand the system, you may be able to throw away that good part of it. And maybe you can start with a set of input that's approximated right where to the input side of where you think that you believe that bug is, where it's going on, where it's exposing itself. In that respect, you get an idea of getting the range, getting the ideas of what's going on. Okay, it's the bug. It seems to be happening. It does this. It's like, well, does it happen with a small input? Does it happen with a large input? Are there particular numbers? I remember in the real world once, in terms of a short war story, I found the foundation for Kent Beck's test-driven development in his argument for the currency model, because there was a Rails app that used floats, and for some reason they couldn't put in a price of $3.87 for a target price for buying an ad. It would drop to $3.86, or it could go up to $3.88. And that's exactly what that was. Eventually we discovered. I shook my head. I explained it to my boss. He shook his head because it was a textbook thing of what not to do with currency. But that was the interesting factor. What was the range? That was the way the bug was filed. I can put in 386, I can put in 388, I can't put in 387 as a price. And that gets back to determining which side of the bug you're on. Knowing where it is, where do things go from everything's okay to this is messed up. That helps you, again, in terms of reducing the problem space. You can use some easy to spot test patterns. This is kind of a fun one, depending on the environment you're working in. Classic thing I know in the C world, I don't know if it's used anymore, but grabbing memory that you're working with and initializing it with OXBADF00D, bad food. So what happens when you do an invalid read? Well, I went to get a valid, oh, I got a chunk of bad food here. Okay, so I got a pointer problem. Surprise, surprise, C. But things like that, things that you can do to identify test situations, test patterns. As bad as it is in terms of divide and conquer, start with the bad. Start where things are broken and work backwards. Well, it's broken here. Well, okay, what feeds into that? Well, this feeds into that. Okay, what feeds into that? Start stepping backwards from where things could possibly go bad. Also, you want to, when you're in there, and this can become an interesting challenge as well. Hopefully, if you're not under the gun, fix the bugs you know about. If you're in a notorious section of the code and there's comments in there about, hey, we've got a bug with X, Y, and Z, bugs have this insidious way of their nature of problems with the design, bad assumptions, or mistakes in coding of like flocking in an area sometimes, right? So you can have multiple bugs, and if you fix one, in some cases you'll fix the others, or if you fix one, you may actually expose another and then be able to easily identify it because you fixed this one over here in the first place that you've been avoiding. You know, well, this happens under stress. Well, why does it happen under stress? Well, we've got a threading and a multi problem. It's like, okay, well, why don't we put in a queue here? All of a sudden the bug goes away, that sort of thing. And then the race condition also goes away as well because you implemented a queue, that type of hypothetical behavior in terms of fixing bugs that you know about. And then for the divide and conquer, this is kind of an interesting one. In some cases, you want to handle it a bit like triage and stop the bleeding. Like fix the noise first. You know, oh my God, it's making this terrible noise. Okay, so can we fix the terrible noise? If you don't get hung up on the minor edge cases and trying to figure out the most elegant way, you might be able to buy yourself some time. This is a little bit of the classic workaround, right? You know, yeah, this is blowing up. Okay, well, let's put in a branch here that works around this and, you know, we'll do something else. And yeah, it's not ideal, but this will buy us time to figure out the cause. Ultimately, as we get down to some of the other rules, as a preview, of course, rule number 9 is if you didn't fix it, it ain't fixed. And this very much ties back into that. Yeah, sorry. So I'm sorry, there's fixing the known bugs. That's fix the noise. It's off by 1 on my clicks. Number 5. Oh, I have made this mistake a number of times. I'm sure others have too. Sometimes we're impatient, particularly if you've got a compile cycle or something else that's going on, but you really kind of want to change one thing at a time. Specifically because if you change more than one thing at a time, it will not tell you which thing worked. So in order to do that, changing one thing at a time really helps you isolate the key factor. You know, it changed something that's, make sure that you're changing something that's in the problem context. You know, don't look at, you know, something off to the side when you've got a set of 3 variables. Don't worry about the time of day that it runs. Timestamp's not included. All right, we've got, you know, a couple of strings and an int here. I don't need to worry about the time of day that this runs. In terms of changing one thing at a time and being patient, one of the stories in the book talked about grabbing the brass bar with both hands. This is a little bit of a slowdown factor. It was a fun story. It talked about the fact that on submarines, nuclear subtraining, there is a brass bar that you're taught to grab onto with both hands and take a look at all of the input information on the console in front of you. Why grab with both hands? Because then you're not tempted to fiddle with anything. It's a variation of figuring out a way to slow down, and as it says, change one thing at a time, but also help you stop and think in your analysis. So yeah, step yourself back from wanting to, apart from changing one thing at a time, going off and just changing anything. Focus yourself and grab the brass bar a little bit. Importantly, change one test at a time. And not only that, but if you see if you can do it from like a baseline set of values, if you're going through, if you have multiple tests, if you go through and you have multiple tests break, or if you have, maybe that's a bad example. If you have multiple things broken at once, it's going to be harder to focus on what you're fixing. That's kind of also going back to why we do TDD the way we do, with one test at a time. Also, compare it with a good one. If you're looking at results, if you got the bad results, and if there's something in common the good results don't, you could be onto the problem. So, things being out of range, a negative value, a null, something like this, what should this do? That's a good thing for focusing on being able to change one at a time. And this is a classic. Determine what changed since the last time it worked. Like I said earlier, did it change before the last update? Did we just do a code deploy? Did it change and was it working just fine before we changed over to daylight savings time? Things like that. All right. Any questions so far? Thoughts? We're about halfway through.
A comment on the the last one, the point you made. Usually you will change some logic, but it's not in the area you think it is. Like you're looking at the area that we changed this file. Usually the change that causes the problem is somewhere else. You realize that later. So.
Yep, very true. All right.
I have a quick question, if that's okay.
Sure.
What earlier in, I believe, rule number 4, you mentioned something called, rule 3. You said that watch out for Heisenberg, and this is particularly problematic with multi-threaded code.
Yes.
What exactly is multi-threaded code?
Basically, what happens is typically when a program runs, and the simplest early computers would only do one thing at a time. So like right now, your PC, as it works, a lot of them can do multiple things at a time. But even going back just to like about 10, 15 years or so, what you see is multiple things being done at a time is really a matter of switching back and forward quickly. So when you do that and you have more than one thing working at a time and code is switching back and forth really quickly, what can happen is that you basically have a variable or a piece of memory or something that's going on, that one set of your computer running one set of instruction and another process in the computer maybe running the same code but a little behind. They start kind of fighting with each other. And because of the way that the computer runs, that it schedules things as it needs to, running through those the same time won't necessarily do every single micro step together. They'll be different just a little bit. And so you get that uncertainty. And then when you come along and you say, well, I want a print statement here, all of a sudden you're doing something different. And so those little micro steps change, and it starts to look like the change that you made for adding in the print statement made an impact to the behavior of the system. And ultimately what you're doing is just you're exposing that you have a dependency here that's not coordinated up between two processes running at the same time, or a way for computer code to be able to share nicely. And that's the type of environment typically that you tend to see those types of Heisenbugs, where you go to inspect it, or you think you're inspecting it, but by doing that, you're changing the environment. Okay, cool. All right, number 6. I will raise my hand and say this is probably the lesson that I really need to learn the best. And I think that a lot of times we're always bad about. Mentioned earlier in terms of yak shaving, slipping into either jumping into, oh, I know what it is, or I know a way to fix this, and not keeping an audit trail, not writing down what you did when you're going through and making changes. This is probably something that I know that I can be the worst about. Pairing can help you save you from this, but suffice to say, when you're debugging something, keep an audit trail. Write down what you did in what order. As best you can, pay attention to details, because when you go back through it, if you're still not solving it, that audit trail will probably become the source of a conversation with someone else when you say, I've got this really nasty bug. Well, describe it. What have you already tried to do to fix it? Well, here's your opportunity to be very explicit about what you did. I tried running it this way. I tried running it that way. I changed these inputs. I, did a total reset. I reloaded the OS, whatever it is. Keep track of that. Sometimes if you go off on a tangent and get lost, that will help you from going off in similar tangents. You say, no, I don't think we should necessarily investigate there. That idea of taking a guess. You might dissuade yourself from taking a branch of guess because you already tried something similar. And so having that to review is helpful as well. Understand that any detail could be an important one. Sometimes it looks like normal input isn't. Fun classic on this. Well, that date format looks perfectly fine. Really? Maybe it's British. Maybe those months and days are swapped. Thank you very much, you crazy Brits, trying to do it a sane way instead of us doing this crazy Americans do, where of course you put the month before the day and then the year. Things like that, little things. The normal input may not be, and things like that will help you as you go through and make notes. Might be the point of a eureka moment, push you towards a fix. Understand audit trails for design are also good for testing. So, if you got a logging system in there and it's easy enough to say, well, hell, let's crank up the logging and then take a dump of what's going on there, and then say, run it through with good input and run it through what's causing the error, and then take a look at the delta in the logs. That can tell you some fun stuff pretty quick. Oh, look, it's throwing an exception when we bring this in. Bingo, getting closer. Those type of tactics can be really helpful. Understand it was wait a minute, that was the statistics. I threw one. I'm sorry, I'm off by one. That was the logging one. What I should have said was correlate events, which is similar to taking a look at the audit trails. Taking a look at a sequence of events, did things behave differently if the sequence changes? Do A before B, do B before A. That can help you push you in the right direction of finding dependencies. And last but not least, if this looks like the first one, it's because it is. Write it down. I'm putting it in there twice for a reason. The original author put it in there twice for a reason, especially if you're under pressure to fix it. Yeah, write down, keep good notes. It's especially if you're under pressure, it can be tough to do, but it's one of those things that will pay off the more so or more significantly out of all of these tips, in my opinion. Number 7. This is a fun one. Check the plug, right? My first experience of this was back in college. a buddy of mine had a work study job, and he worked in the school IT lab for one of the computer labs was his to run. That was his job, which is kind of cool. And he'd get calls on his cell phone. And one of the first things he'd ask, okay, is it plugged in? No, don't. No, go and look. I heard that call over and over our senior year, every time, because we were hanging out constantly, working on final projects, 400 level classes. Miles gets a call, and we're like in the background, me and my buddy Charles, is it plugged in? Running joke. And 9 times out of 10, that was how he saved himself from having to say, guys, I got to stop studying. I need to go down to the lab. So check the plug. Question your assumptions. Is it the right thing? Is it hooked up? Is it connected? Is it plugged in? Question those assumptions. Also, this will look familiar. Start at the beginning. Okay. You've gotten far. We're up to step number 7. We've done all of this stuff. Double check those assumptions. This is a little like knowing the system in a way, but it's really like checking the state of the system in that regard. You can kind of think of rule number 7 in that sort of an effect. And here's a fantastic one. I know folks have been bitten by this before. I've been bitten this before. Test your tool. It's like pop open the browser, put in the URL, and the site's doing this. Production is doing this. Look. It's like, what happens if you give that in a curl command? Do you get the full page? Does it work? Does it show up? I had years ago, had a panic when, or colleagues of mine had a panic that took a good 45 minutes to an hour. It looked like the live site was screwing up some content. Long story short, it turned out to be a plugin on someone's browser that was modifying some CSS values and throwing things off because they had a development tool that was turned on. And it was the team lead. And he was like, no, guys, look, this is a problem in production. Everyone flocks over. Oh my God, check this, check that. Plugin. But yeah, test your tools. Here's the other fun one. If you have the fortune of working in a pair or a mob environment, you've already got a huge advantage on this because you've got more than one set of eyes looking at it. As Linus Torvalds always used to like to say, with enough eyes, all bugs are shallow. But if you're going through something on your own, get a fresh view. Ask for fresh insights. The challenge, one of the interesting challenges about this, go ask someone else. She's not here now, she'd popped up earlier. I could explain it to my cat. I could grab Boo and I say, Boo, I've got a problem. She's not going to give me good feedback, but it's an interesting part of the human thinking process that the way that we process information verbally activates and goes through a different part of our brain than how we process information if we are writing. It's just a fact of the nature. You've probably experienced this where you've got a problem, you get up, you go to talk to someone. By the time you're halfway through explaining it, you go, oh crap, I know what I need to do. If that doesn't solve it, tap an expert. Find someone who knows more than you. If you're an expert, then go find a genius. Someone who knows stuff about it that you've not even considered digging into, even if you consider yourself an expert. Overall, you want to listen to that voice of experience. In some cases, when you get down to well, it seems like this is happening, they may be able to help reinforce that, yes, something like that can happen. In fact, here's that weird edge case where that can happen. Do you have any of these factors? That may help you steer away from excluding some of those more bizarre edge case type of things. And overall, the advantage of debugging things in the modern world we live in, help is all around you. You've got coworkers, in some cases there's customer support, the web, all sorts of things, news group, digging through Google, although a lot of cases that's where you start. But as we all know, depending on what you're searching for and how, you can get a lot more noise to signal too often for the things that you're trying to dig into. But it's a level of help.
Hey, Garrick,
Yes.
the one thing when you mentioned that kind of really threw up the light bulb in my head is we were totally looking for something, we were having a problem with it and couldn't find, searching on the web, couldn't figure it out. And then another team member came in and changed the search, right? Like we were searching for how do we do this in React Native, and he just changed it to React Native, how do we do this? Like flipped around, and we totally hadn't thought of that, and we found the answer that way. So it was just
that
interesting.
makes you lose faith in the Googles, doesn't it?
Yeah.
Great example. Another thing in terms of getting a fresh view, it's kind of hard coming up with an icon for this. By the way, I'll mention this later on this, but all of these come from a service called the Noun Project. All these images that I've thrown up and used for my presentation. Since this was originally a hail of bullets that you could have read along, but I wanted to get something a little more engagement. So shout out to them for having a great kind of fascinating wide set of icons for all sorts of different topics that you can license and download and add to your presentations, website, etc. But this one in particular, since you're problem solving, don't be proud. Nobody's perfect. Bugs happen. As the author puts it, take pride in getting it fixed. Don't be ashamed that it happened. Be proud that you fixed it. I guess is a good way to look at that. And then one of the difficult ones, because I know that I've made this mistake in the past, and it's something that we tend to do, especially when we're sharing information with other developers who also know the system. Oh, sorry, I'm jumping ahead. Yes, no, this is it. You want to report symptoms, not theories. So when you go to talk to someone, you don't want to poison the well. You want to say, this is what's going on. These are the symptoms. These are the things I've tried. Don't necessarily say, I think it's over here, because you may get yourself a whole bunch of folks going off in the wrong direction. Mordor is that way. You're going the other way. You're headed towards the Shire. You're not going to get rid of the ring that way because, hobbits will eat anything, but I don't think they're going to get rid of that ring for you. So, don't poison the well overall. Just report the symptoms. And it can be hard to do because you want to say, especially when you've been working on something and you're frustrated and you're just like, gosh, I've tried everything. It's like, no, you fool. Don't you think I would have tried that? I tried that already. It's just like, just set those aside. And more importantly, when you go through, understand you don't have to be sure. If you've got data that's confusing, or you've written down stuff that seems like it shouldn't matter, because that can't happen. That's why you're tracking it down anyways. You're going to get more information than you need. You've got, stuff that may seem unimportant, but when you're trying to get more input, when you're trying to get a better understanding, share what you have, and you don't have to be 100% sure. So we're up to slide 9. Sorry, we're up to slide 8. The very last rule, as I mentioned, if you didn't fix it, it ain't fixed. And I love the little quote, of course, that I put in here. The way I like to say it, it seems like it's working now, said giving comfort to nobody ever. Whenever something happens and a bug just goes away, that's the worst. Because you just get that sinking feeling that somehow, somewhere, probably at the worst time, possibly when you're on call, depending on the situation, that it's going to pop up again. So when you think you've got a fix, you really want to check that it's really fixed. Don't assume the change you made was the only change that was needed. Sometimes you'll get situations in systems. There's an anti-pattern, if anyone's familiar with, it's called shotgun surgery, where in order to really fix or make a change in refactoring, you actually have to go through and fix it in multiple places. Sometimes you get stuff that's related to that, where you get the shrapnel bullet, right? Where you've got one thing that's the predominant thing, but it also depends on this element over here. So that's the checking that it's really fixed. Going out, double checking and verifying the production, making it sure that that thing doesn't pop up in the log again. That's probably one of the most important factors as you go through, not simply saying, oh, I wrote a failing test, I fixed it now, I put it in Jira, it should be fine, and going on to the next thing. You don't want to do that. You want to validate. This is an interesting one. Checking that it's really your fix that fixed it. I don't know about anyone else, but I've also run into this too. If you didn't reproduce the cause correctly, your fix may have fixed a bug, but not the bug. Anyone who's ever run into a variation or a compound bug, you'll know exactly what I'm talking about. This can be hard to validate, but it's part of that end validation of checking that it's fixed, is making sure, in some cases, really trying to stimulate and really go through the exact same input if possible, and making sure that that bug doesn't pop up again in the exact same way. Also, you want to know that, as we mentioned, it never just goes away by itself. That's a little bit of the core. If you didn't fix it, it ain't fixed. But in those situations, it really goes back to the original make it fail approach. Interestingly enough, if you're under pressure in a lot of cases, this may be the reason to introduce, possibly introduce like a bug trap, so to speak, right? Sometimes you might need to come up with something that's a little bit of a workaround, but that's still not necessarily addressing the problem. So for example, is again, somewhere down in the code, someone handed you a null. It's like, and you missed the null check or the null guard going through, and you wrote a test for it. That's fine. Now you really got to ask yourself, where did that null come from? I'll throw out a fun generic spoiler alert, could be the database. How many times have we seen that, folks? Oh, that can't happen. No, somebody missed something, and we're pulling stuff out of the database. We're not validating it, and we're cranking it all the way through, and we blew up. We caught the bug. Well, you're isolating the bug, but you still have issues in your problem domain in that exact situation. That's a classic. Why was that null there? If that null was something that never should have gotten into the database, maybe the real bug is back at the call center's input tool. Somebody made a mistake there, and so that null is getting into the system. So you still haven't fixed the root cause of that bug. That's a classic. So yeah, fix that cause, right? That null in the database was caused by getting some bad input. Fix that, and you wouldn't have had to have written that null guard, but you should have anyways. And then, of course, here's one of the biggest challenges that we run into, because there's always so much to do as developers, because there's only so much time that we have. In some cases, when bugs come up, it's the process, right? There was some process, and maybe it's a process that we changed that exposed the bug. We did B instead of A this time because we were in a hurry. And now someone simply steps back and says, okay, well, that's fine. Well, from now on, we just need to make sure that we do A and then B. Someone's going to make a mistake in the future. And you start to ask yourself, what can we do or put in place that if someone does B before A, B fails? Maybe we've got a validation step that we need to put in the script for B. Or we've got some sort of a dependency check that makes sure B can only be run if A is run. That's still a better step. That improves the process. But if you've got something that simply comes along, that simply goes ahead and, you know, we end up with a procedural workaround, you're masking the problem. So change the process so that you don't mask the problem, and then you've really solved it. And that was the 9 rules.
Nice. Thank you. It sure brought up a lot of memories of yeah, having to sit and go through the debugger. And you know, I very much actually like the very last one of fixing the process. I was working with a company, and they had a like they had to make changes manually in the database for some things, and it caused a bug because someone forgot the just like delete star and forgot the from clause, you know, and awesome. And we were going through and talking about it, and one of the other developers said, where else are we manually updating the database to delete things?
Yep.
Right. Because we were like, well, we fixed that. We'll never do, well, we wrote the script that would just delete that table for the stuff we needed. Like, you know, that process issue definitely brings up some issues, some areas that you could make better. So love that.
Yeah. Sharing a war story with that. I have a very similar story to what you just said, Paige, with changing the process too. With my friend was working at a place, and you know, they were doing a lot of tests. They had access to beta, pre-prod, and prod databases. And oh, well, the prod database has a red terminal. That's the way you differentiate if it's the production database. And oops, accidentally dropped a table in production, dropped the sales table for this sales company. It's like, it was red. What do you mean? Why would you drop the sales? And like the latest backup was 3 days ago. They had to call customers and say, what did you buy? We need to put that back on into the database. And like, why did you do that? You know, we should fire you.
Oh, wow.
And yeah, don't use a color to differentiate what database you're using. I don't know if they learned their lesson. I think he left, actually.
So I also, in terms of questions, I'm curious if people have specific favorite tools, either, you know, debugging or monitoring, or any tactics in general that they particularly like to use.
I like JetBrains debuggers. They're just nice. They're detailed. They're easy. They work. So that's me. But for most of the stuff I work on. So
I mentioned it a while ago. I'm curious, has anyone I have. I'm wondering if anyone else has found that they begrudgingly fire up Wireshark in order to figure out what the problem is. I know it's been a while, but I have run into that, and it's been typically like some weird header or handshake information or something like that that's gone on that's been obscured. But that's literally an example of like going to the metal, specifically, you know, for web application stuff. But because there can be a lot of noise, but I know that has been helpful in the past.
My domain is generally like, you know, business processes. So it's all, you know, automated running stuff where you really don't have a UI end. Mm-hmm. And from my perspective, we're currently on the journey of making things better. But the things we're seeing are, really hammering on observability and manipulability. So specifically, like on the manipulation front, you know, talking about having to make production database changes, is that, you know, we're developing a culture of every time that we are looking at some process, we are building in a kind of a manual hook that we can say, all right, if this is going to happen automatically, we need a way to trigger this manually, you know, from like an admin console or something like that, to be able to for one, like it from a development standpoint, you can build kind of the last step of your pipeline and poke the button and see that it works. And then you can build the next stage that feeds into that and poke the button and see that those two things work. And kind of that, you know, small iterative process of building up your functionality is pretty incredible for making sure you're doing the right thing and building that confidence. But then the other side of that really, really is a win for us is observability, right? Is for us, you know, we don't have a good way to see what's going on. So we need, you know, it's all of our log outputs and checking out, all right, we know that something happened. Let's see how we got here by looking at our log aggregator.
Yeah.
And I know that I am eagerly waiting for the folks at Honeycomb, Jessica Kerr and Liz Fong Jones, and some of them have a book on observability engineering that is just released, and I am kind of salivating a little bit to get my hands on it, to get a look at, you know, and a really kind of organized and methodical way to plan out how do you, you know, instrument your observability well, rather than, you know, currently it is kind of like a live binary chop, right? Where something goes wrong. We think it's in this neighborhood. Let's slap some logs in there and see what happens. All right, we came in the next day and we see these things, but it didn't get us all the way. So now we're putting some more focus logs because we saw something changed over here, but we don't know what it means. So those two things in combination are really kind of my quality of life indicators.
Cool.
Maybe a comment here regarding the observability part. Like, of course, like logging is very important, but like if you have especially some kind of like microservice architecture where you have more than one deployables, a thing that is, I believe, extremely important is that you have some kind of tracing tool so that you can see like if you have calls between services, see what's happening. Because like if you have to go through different logs and from different services, it's very difficult to get the holistic picture, and you need a tool so that you can dive like in depth and see like, okay, what are the subsequent calls that are happening. So I think this is a very important part of the tool chain.
Yeah. Nice.
So I'm over in enterprise legacy land, and my number one tool for dealing with that is git bisect and all your other git history archaeology tools, because it's always nice to know that 6 months ago someone checked in a change that just now exposed a bug that was written 10 years ago. It makes it much easier to fix when you're like, okay, enough by one error from 10 years ago. That's easy to fix, but it was hard to find.
That's interesting. Are there any efforts to dodge that by getting test coverage built, or is this the type of system that they're trying to keep the cost down on, so they're just patching?
Yeah, I mean, test coverage is now at 3.5%, so it's hopeless in that regard.
Wow. Okay. Well.
Yeah, when I say legacy, I mean it's producing a lot of value.
Mm-hmm. I'm seeing a great OKR of double test coverage percentage.
Yeah, right.
Yeah, but that's like 50,000 more lines. So
Yeah. Interesting. Cool.
Okay.
Okay.
I just wanted to mention one thing. I'm working on an open source project that doesn't have nearly enough tests. And unfortunately, they've decided that any method you change, you have to have adequate test coverage, which is 80%. And so it's like you put one line into you basically want to add some functionality. You put one line into one class that calls another one, which has all the new code, which is fully tested. But now you can't get a PR for that because the one line exposes, 100 lines of code that has no tests. And so then you basically spend literally twice as long writing the tests for the code. You had no knowledge of what it actually does. All you knew is that this thing had to happen here.
Right.
Just real quick, when you say you couldn't get a PR for that, is that a production request?
No,
Is that
it's a pull request, basically getting someone else to be able to approve it so it can be merged into mainline.
Okay, got it.
George, I'm curious. Have you looked at approval tests as a way to possibly like generate the stuff around that?
I haven't.
It sounds like this is making you go, I don't know that I want to be involved in this.
Well, no, I'm just saying it sounds like it's the we've been on a lot of teams, and one of the teams, like, they had really high test coverage. The test didn't test anything. They just made sure everything was called.
Mm-hmm.
And it was like, or my favorite one was, it's testing Mockito. Mockito actually returns what I told it to return. And it's like, oh my goodness.
Yeah. Missing the vision.
Yes, exactly. And so when somebody says, approval tests, part of me thinks that's almost like, well, this thing will call everything to make sure it's actually in the coverage thing, but it doesn't.
It could be a helpful bootstrap. It could be a helpful bootstrap up.
It's going to help replace pinning tests. If you're trying to get the thing under test and it's really big, it's a lot of effort to write all those pinning tests by hand. So it's such a useful dependency to do that for you.
Yeah, exactly.
Oh, interesting. Cool.
I had a thing regarding the number one, understand the system.
Mm-hmm.
When we were going through that, it reminded me of a time where actually the team I was working on, we were doing like a large scale, kind of like a, hey, we need everybody to do this. Users of our system, we need you to increase something. And on top of that, we started noticing some of the data was a little wrong, a little wonky. And it was like, I don't know if there's a problem, but maybe we should look into it. So me and somebody were looking into it. And it was a legacy code base. And I say legacy because a lot of it didn't have tests, was very hard to understand. In working with it to try to figure out what's going on, we just refactored to Insight. Common technique where we're taking this code, we're trying to see if there's a bug. I don't even know what's going on in it. So I'm refactoring the code. We're only doing safe refactors, automated refactors using the IDE. And doing that, it was such a great way to understand the system. And we started to actually add in pinning tests because we're like, oh, I think it's doing this. Let's validate it's actually doing that. And by the end of it, we got it to where like we're automated refactoring. We're moving it towards more of the domain names, the names that the product owners are using. Yeah. We got to the point where I went to the product owner's desk and I said, hey, pull up this URL to the GitHub link. Right here's the bug. And it's like, you said the logic's supposed to do X. Here, I'm showing you that the logic is doing Y. Yeah. Let's change the code together.
That's pretty cool.
And yeah, so I think that's something I usually pull on instead of just looking at, oh, here's the documentation for that. It's like sometimes get down to the code.
Yeah.
Do I understand the code? No, let's refactor it safely to see what's going on.
So you probably have heard or read Arlo Belshe's comment about when you're restructuring the code, you cannot fix anything.
Mm-hmm.
Because you're changing the code and it should behave exactly the same. Anyways, so I'm working with this pair and I see this the previous developer, who apparently was brand new as a developer and to the company when he did this. He actually is changing the value of variables inside a conditional debug thing. Mm-hmm. And it's like, and as a contractor, I didn't have access to production. And I said to my pair, I says, we have to keep this in here because I don't know if debug is active in production. And so,
oh, wow.
Yeah, mind you, I put banners around it. It's like, dude, this is not good.
Here be dragons, really.
Right. But I had to leave it alone. And it's like, oh gosh, leaving it alone felt so dirty.
Yeah, no, that is definitely a challenge. Definitely a challenge. Cool. Okay.
Maybe one more thing. So like when you're debugging, there are also different contexts that you debug, right? Or like you are trying to solve a problem. Like it might be an incident, or you might be coding. And I think, like you mentioned it at some point, I think at number 3 or 4, that sometimes you know, just turn it off, that part of the code or whatever. And I think this is especially important if you have an incident. Like the main goal when you have an incident, it should be that you just restore the production, right? Restore operation, even if you don't fix the bug.
Yep.
Like sometimes you might just be able to throw more resources at the problem and it goes away, and then you can like investigate it on your on business hours, not on while you're on
Yeah.
call.
Yeah,
Or just-
sometimes that is a great example when there's when it's high stress and an immediate fix. That whole notion of stop the bleeding. That initially the right thing to do is maybe the kludge, the hack workaround, this is horrible, but we need to stop the bleeding to save the patient, or in this case, to make sure that the company doesn't go under because the website isn't responding, right? But yeah, absolutely, I agree. And sometimes it's interesting because you get weird classifications of stuff. I mean, things that a lot of us have run into, especially when you get processes that don't run constantly. That interesting factor of 20% of the code is run like 80% of the time. But it's like, well, we've got this end of the month report that loads X, Y, and Z. Those are the ones, it seems like, always end up with the weird bugs, the edge cases, the let's just throw more memory at it because we used a document object model in order to do the import instead of using a streaming model. And so, when we were a small company 5 years ago, that was perfectly fine. But now we've got all this client data and it's blowing up. And everyone scrambles and says, what's the quick fix? It's like, well, throw memory at it. And then the challenge becomes, okay, so at what point do we convert this import to an XML streaming so that we're not having to beef up our server? Like I said, I don't know about everyone else, but run into that one multiple times, and the weird thing is that it's only at the end of the month, so it's infrequent, and it's not something that, while it's vital for business, whatever that billing or processing is, it's not something that is visible to executives. It's not something that's impacting the company, but at the end of the day, it's one of those things that you have to bring up as a responsible developer and say, this is the part of the system that has this technical debt in, and we need to fix it, instead of doing these new features that the sales guys are hot to get done because we're not going to handle another 2 months.
Yeah.
So I'm going to jump in here and just sort of do a little close. And it doesn't mean we have to, if you have questions, you can't continue to ask them, but I want to say thank you very much, Garrick. That was really enjoyable and very educational. And I think I got some stuff out of it that I can totally, hopefully push on other people I work with. How about that? Do this. Garrick says, do this.
Well, technically, it's not even me who says it. It's the original author of the book here on the previous slide. What's his name again? Yeah, David Eggins.
Excellent.
David Eggins says this is the way to do it, and it's the framework for whether it's hardware, software, or and troubleshooting your nuclear submarine, apparently, according to his war stories. So.
Excellent. Well, thank you very much.
Thank you.
thank you everyone for attending. Really appreciate it. Whether you're a first timer or you've been here before, it's always good to continue the conversation. Next month we have Martin Peltier coming to talk about freedom and happiness at work. And then in August, Dustin Thorstenson is talking about if you're fighting, you're failing. And so those are upcoming, and have a great month, and we hope to hear from you. See you next month. Thank you.
Awesome. Thanks, seeing everybody.